All right, and then I will share my screen and we will begin. So for you and all in the recording, another welcome to our Tuesday evening Beijing time, 7:30 a.m. workshop series from the Wenzhou Kane University Office of Academic Affairs. I am Jace. I'm glad to see you all back, and hopefully some of these sessions have been useful. I really hope that I know you're busy, and I'm so glad that you're able to find the time for these, because the way that any learning, and especially faculty development, works is that we kind of pick up some of this information at the right time, and it's not all at one time. I understand that I think the university used to have a faculty development day or days in June, and I think for whatever reasons it was the thing to do at the time, but I'm hoping that we're doing more what's called distributed learning. I always remind people, we don't eat one meal a day, we don't sleep one time a year. We have to constantly kind of have this input of information and connection and stimuli. And I give this all as a preface because that's really what today's session is about. When we say this term learning theories, some people may start to hear those words and they know what learning is and they know what theory is, and they may or may not really put this together. So today I'm going to go through a very abbreviated, again, this is going to be a nice 50-55 minute type of a session. I won't pretend that you will know everything that you ever need to know about learning theories, because this is an entire PhD program that really can get very complex. There's only one central thing that I would like. I'll share the outcomes in a minute, but even broader than a learning outcome for this session is I would encourage you to walk away with one thing. If you could focus in on one item, one concept, and that is really pretty simple, is that the information that I share with you about how our brains work, I would encourage you to just find a way. You can write it on a Post-it note, or you can find a way to keep it in mind that when you start to do things with teaching, when you plan, before you walk into the classroom, when you're in the classroom, when you're lecturing, when you're asking questions, when you're developing assessments, ask yourself one simple thing. How are the students processing this? Not my words, but this, the interactions, the ecosystem, the environment, the context. How are they processing that? How are they making sense of this? That, in a nutshell, is really what learning theories is all about. There's several ways that they've broken this down, and I'll share those with you. But at its core, that's what we should be doing as instructors. And you'll find, chances are you're a good instructor because you're here. Most of the time, people who join these sessions are already a bit self-selected in caring deeply about teaching. So you probably ask yourself a few of these. And I find that when I give this session, most of my colleagues will say, oh, so that's why this works. That's why I approach teaching in this way. Oh, I didn't know what you called that, but I used similar terms when I wrote my teaching statement, my teaching philosophy. I understand now there's actually research behind all the things that I've been doing. So, and I would suspect that you're going to have similar thoughts after this session, that there's going to be some light bulbs that come on, not light bulbs in how you should do things, but light bulbs in awareness of, now that you know that things work or don't work in your classroom based on foundational learning theories. So here we go. Let's go ahead and remind us that this is our fourth in an 8-part series. Well, after today, we're halfway through our sessions, and we have some more that will be ongoing throughout the next couple of weeks and throughout the semester. The learning outcomes for this session are pretty straightforward. I think that I really focus on this term apply, and that's why I had the initial screen of application versus theory. A lot of times people aren't that interested in learning theories because they think that they are kind of theoretical. They're out there and they don't really do them a lot of good. The real goal here is to apply those learning theories into your teaching so that indirectly, subsequently, students can learn better. And that's the whole point of this, is that everything that we share will simply be a way so that you can, if you haven't already, is that you can kind of firmly implant kind of a lens on your eyes, on your mind, on your teaching strategies, so that you start to look at things that you create, maybe you don't do, but you structure and you plan and you offer and you facilitate these activities within your class, within your teaching sessions, so that every time you do it, you're doing it with intentionality. You're doing it with, here's what I'd like students to be able to, as we say in our outcomes, know, do, and believe. And then finally, I'd like to, ideally, if you are starting to plan, design, redesign classes, to think about how you might propose some connections between the actual learning theories and your teaching, the learning, which includes assessment, and then the design of your course. I would like to get us a little more active, nothing hugely active in this session, but I would like us to start. And I'm doing this in purpose. I try to walk the walk of, I know the learning theories pretty well, so I'm trying to think like, where are each of you? It's a little more challenging to work with faculty because you have so many different disciplines and approaches in life. But I'd like for you in the chat, just stop and pause for a moment and just write a word or two, whatever you feel like doing, a word that describes how you hope your students would describe you as an instructor. So fun, happy, smart, good, whatever that might be. Hopefully it's not boring or lecture oriented or those kind of things, but just write one word that you hope your students would after they leave your class that day, that week, after the semester, and someone brings your name up to a friend, they might say, oh, they were blank. Now I'm doing this on purpose because I want you to start to think about that word, because you may think about some of your colleagues and you may hear some of your students describe some of our colleagues in certain ways. That doesn't happen by accident. I firmly believe that happens mostly because those, if they're positive terms, obviously positive adjectives, those things happen most likely because the faculty, even if they're unaware of the complexities of learning theories, their instruction, their way that they're facilitating the student learning is grounded in learning theories. And so you see why I'm bringing this up now. I want you to start to think about what those words might be. And then I'm going to be very transparent here. Throughout the next 50 minutes, I'm going to try to help you use some of the strategies of learning theories to make that come true, to make the whole concept of what students are thinking about you come true. Excellent. So I'm reading some of these, right? Feel free to read each other's: caring, organized, responsive, organized, responsible. Great, great, great. So those are things that, again, they may happen anyway. I would challenge that they're not going to happen by accident. You have to actually be very intentional about those. With all the workshops, I always try to make sure that people receive the research. This happens occasionally, that some of our colleagues will say, they'll be talking to another friend, and maybe this has happened to you, and they'll say, well, I was talking to Jace, or I was in this workshop with Jace, and Jace says, when actually the words came out of my mouth, as they will in a moment, but when I say things like this, it's because I'm actually just sharing research. This particular research comes from a very, very foundational book by Ken Bain. He's updated these editions, but basically what he did, he took about 20 years, he collected data on what the best college teachers do. And he wrote that in a book, and I'm going to kind of abbreviate that and share some of those findings in about 5 or 6 bullets. It hopes that, I'm assuming that you would like to be a best college teacher. And the first one I have to say, obviously, is why I used this research for this particular workshop, is that the best college teachers know how we learn. Now, that's a shortcut way of saying they understand and they integrate learning theories. So to know how we learn is basically the process of, what are students thinking about? How are they reacting and responding when I do this? When I'm writing on the board, when I'm asking questions, when they're in group work, when they're doing homework? Have I thought ahead? Have I thought, at least intentionally, What is it that I would like them to be getting out of this? Now, some of us treat it like a game show and our students win or lose, and we kind of hope that they get certain things out of it, but we don't build things into the system to know how they're processing that information. And that's why we talk about things like assessment, informative assessments, and checks and balances, and those kind of things. But the number one thing that the best college teachers do, and that's why I'm glad that you're joining this session, is that they do know how we learn. Secondly, they basically teach as a serious intellectual endeavor. It's not something on the side. It's not something they do at the last minute. They prepare for it, which means they understand how we learn. They understand how people process and connect. They plan. They check how the plan works. I mean, would you build a house and just start nailing boards together and not step back and say, hey, is that looking like a house? Is that standing up straight? So they teach as this very serious thing in their life, not as a sidebar. They assess their own efforts. They don't wait for a department chairperson or a dean or a vice chancellor to come by and give them a piece of paper that says, yes, you're doing good stuff. They create their own mechanisms to do that. I'm happy to help with that. When we build the Center for Teaching, they'll have mechanisms and forms and processes that can help you with that. If you're the least little bit interested in that, let me know. I can share with you some ideas on how you might start to assess your own learning. One of my favorite, which is fairly lengthy here, but the best college teachers create environments. So this is a little bit different. Sometimes people think that the best college teachers are the best lecturers, or that they're the smartest. Don Finkel has a book called Teaching with Your Mouth Shut, and he focuses on this concept of we can't really teach anyone anything. All we can do is create an environment for students to connect, discuss, process, right? You're seeing this central theme of how we can actually do this, and realizing that we have students from all over the place. You may think that you have a homogeneous group of students because maybe they all speak the same language, or they might look similar, but learners are from all over the place in their mind, cognitively, their background, their abilities. These are the things that we should be aware, and therefore we need to understand that learning theories will allow us to create environments that are accessible, that everybody can kind of see, oh, I'm looking at it a different way, and I can connect this to my schema, my previous knowledge that I might be using, and they can construct some information. And the last thing from one of our previous workshops, as you might appreciate, is that the best college teachers teach as research. We talked about this at length. We called it the scholarship of teaching and learning. But when they teach, they're constantly asking themselves questions. Now, it may not be complete hypothesis, or it may not be research questions, but they're constantly saying, did that work? How do I know it worked? How much did it work? Would it work again? That's teaching as research. Now, I'm almost positive that each one of you are doing that. I would encourage you to find a way to document that, even if it's a small way, right? After class, write some notes about what worked, what didn't work, what you might do differently, tuck it away in your plans, and so that the next time you teach that, you might be able to update the design of that session. And feel free to, I think that Ken Bain's book is available on the Winjo Kane library system. If not, I'm positive it's available for free to check out and read on the Kane University Learning Commons. If you need help with that, let me know. I'll connect you to Muhammad Hassan, the director of the Learning Commons. So how does learning happen? I mean, this is, again, sometimes people see these slides and they say, well, Jace, you're just talking common sense. I mean, this is all, everybody knows what the word learning means, and everyone, oh, I'm here to tell you that everyone has a very, very different viewpoint of that word and how they enact it. So I'm going to share two different ways, an anatomical and an operational. So the brain, for you folks that are recalling now, and maybe you're feeling good about this, maybe you're having traumatic effects of your biology class or your anatomy physiology class that you took in your secondary or tertiary programs, and you're thinking, yeah, I remember neurons and synapses, and wasn't quite sure. I know that I got an A on that test, but I don't really know what they were for. But basically, this is what happens, right? You have these neurons that we have at birth, and we grow some of these. And it's really the connection between those neurons, these spaces, that allow us to transfer electronic energy in the form of information. And so the larger they are, the quicker they are, the more chemically catalyzed they are inside the brain, then you can get this information that kind of goes a little bit quicker. So one sense is simply physical, right? Biological, anatomical. The other, some people obviously, before I get to the operational, want to know about these neurons. If obviously more neurons is better, can I get more of those? And of course, there are ways to do that through diet and exercise. And this is a slide that people tend to like. They usually do a quick checklist of, am I eating those? Should I eat more of those? Things like, these are examples, right? Blueberries, omega fatty acids, green tea, so forth. I do mention the dark chocolate. I want to always clarify that it's dark. Most of the research that I've read indicates that that has to be 72% cacao or higher. Many people tend to get a bit sad at that because that's the more bitter chocolate. They're eating typically milk chocolate, which has extremely low cacao percentages. So I'll leave it up to you what you do with that. But if you're thinking after this, oh, I'm going to get smarter by eating Hershey's milk chocolate, not going to happen. Not going to happen. It will do something to your body, but it will not be growing neurons. I'll leave that up to you. Now, the second portion, which I really want to focus in on, because it's going to really align with our outcomes for today, is I really appreciate Shunk's definition of learning. And he has three basic facets of this. He believes, and he has seen, that learning is this behavioral change, or the capacity for that behavior to change. And you may have heard me use this term occasionally, of behaviors. As a chemist, we didn't think much about the behaviors of our molecules. We measure the molecules and we measure their interactions and how they can bond and so forth. But with humans, we actually have to kind of look at their behaviors. And social sciences is an amazing, amazing thing. To me, it can be extremely frustrating because it's not there's a lot of shades of gray and a lot of interpretations. And if you're going to kind of go down this road, which you are as an instructor, right? Teachers are social scientists, whether you like it or know it or not. You're trying to work with our students, which are humans. They behave like humans. They react like humans. And so we want their behavior to change. And to qualify this, a behavior could be how a particular person responds or writes answers on a test. That is a behavior. I just want to qualify that may be something, if that's one of your students' goals. I will say that behavior doesn't really correlate with much. How people behave on written tests correlates with how maybe writing skills, or how well they can circle bubbles in, or maybe reading capacity, but it really doesn't correlate to success or actions or skills. So you want to think about that behavior. If you really are concerned about how students are learning, you want the behavior that you want to elicit to be authentic. You want it to be correlated to the skills in your discipline. If you're an accountant, you would like for them to be able to do accounting, which might include spreadsheets or some sort of mathematical skills. As a chemist, I want students, as an environmental chemist, I want students to be able to walk outside and sense and see and observe and look at stress vegetations and gradations and maybe what has happened with various contaminants and their migrations and their attenuations, and just really be keen observers and be able to take notes and field notes, and accurate, quantitative, qualitative. So that's what I do in my field. So therefore, the kind of behavior that I would, and the kind of behavior that I will then consider that they learned, would be those types of behaviors. Hopefully, Shunk talks about that this learning, that it's going to be a change in behavior, but it should endure. And this is why when people say, well, I got an A on a test, and a week or a month later, they may not know that particular concept. Most social scientists would not qualify them as having learned the material because it didn't endure. And that's why we all know the research on this, that when students, they cram or they study at the last minute and they write a right answer down, then if they don't know it after that, it really didn't do much good. There's been multiple research papers on all kinds of university students who were crammed and they got an A, and then a week later, a month later, a semester later, they took the same exact exam and they failed it. So I don't know, to me, that seems like a waste of time on everybody's part. I mean, I'm not sure what good that does anybody. It does give a student an A on the test, and it does make it appear as though they know that. But when they go to their job and their boss expects them to know it, now we're talking high stakes. We think that tests are high stakes, but they're really not. They're pretty low stakes when you compare them to life. So I would encourage you to think about what kind of behaviors, how are we going to assess those behaviors, and how are those going to endure over time? We know quite clearly through the research that engagement is the biggest factor that allows people to have behaviors that endure. Think about the things that you do, from making coffee in the morning to driving to work to whatever those are. Those are things that you've engaged in deeply. Therefore, it's going to endure. Many times you probably drive home from work and you forgot how you got there because so many things have been automatic because it has been enduring. But now I ask you to think about a concept or a test that you took. Maybe the neurons, maybe you're thinking, yeah, I remember those, but I just took a test and I forgot about those. So it didn't endure. I think that we both would want these things to endure in our students' lives. And the biggest thing I love about Schonk is that he talks about that these, to learn, it has to typically occur through practice or experience. Now, some people will say, well, my students are having an experience with a multiple choice, fill in the blank bubble exam. And I will say, well, great, then they will have those skills. And if they apply for a job and the job description is that you must bubble in circles, they're going to be spectacular at that. They're going to really do well at that. I've never seen that job description, or I don't think it exists out there. So you want to obviously provide them practice and experience that aligns directly with the skills that you, as the expert in the field, what these are. So I'm hoping that this kind of helps us understand the operational side of learning, but I'm also hoping that this is kind of, merging into this concept of assessment. You hear me talk a lot about skills and behaviors and so forth. Kind of keep in mind that teaching and learning and assessment are all one big kind of concept, and they aren't kind of compartmentalized. You've got to think about how those might work in themselves. So these are some questions that if we give a live workshop, I typically pose. Feel free to answer any of these in the chat, or you can answer them verbally or to yourself or on paper. But these are the kind of questions that I hope that you're asking now. I hope that you're asking your students. I hope that you're encouraging your students to ask. This is a part of what we call metacognition, is thinking about thinking. And I think we do it as experts in the field, but our students probably don't. Sometimes they think a little too linear of what is the answer? What is the answer? What is the answer? Instead of, how are we really learning this? How do we know that we learn this? Are we doing a quick check on this? Or, oh yeah, I think I know it. I just read an article yesterday about reading, rereading, and reviewing text. Students think that by rereading text, it will help them out. And they've shown that there's been literally no significant gain in use, retention, or understanding of that material just by reading and reading and reading and reading. Let's face it, we've probably all done this. Maybe we've taken out a highlighter and we've highlighted a few words. I hope I'm not shocking you by saying it doesn't work. It doesn't work. It doesn't work. We think it does. But did I say it doesn't work? That's not what works. What does work is engagement, is practice, is some sort of activities. Those are the things that work. And I know I've been there and I still struggle with it, that the easier, more efficient thing to do is to have our students read, look, lecture. I would strongly encourage us to think about giving up some of those efficient things, going for some of the inefficient things, digging deeper on the activities and engagement. It will pay off for you and the students if we design it well. Great, thank you so much for contributing to our response for item number 3. Definitely intrinsic motivation is going to be key for item number 3. What factors can block the learning? And I think for the number 2 and number 3, I hope that everyone is sitting back and thinking, when I was a student in primary school, secondary school, yesterday, when did I really learn something well? What was going on? A lot of times people will say it was the teacher and how friendly they were, and that's a part of it, but it could be the environment. Was it a big class, a small class? Was it an active class? Did it smell bad? So I was at one class years ago in a large lecture hall, and it was so bad smelling. It was like 1970s sweat socks and old tuna or something. It was horrible. And I thought, if I were in this class every day, I wouldn't feel very inspired. I certainly wouldn't be able to process information because I'd be holding my nose the whole time. So these are things that isn't just as simple as how well is my writing on the board or how clear is my PowerPoint. It's everything. When they come into that classroom, do they feel welcome? Are you greeting them? Are you saying good morning? Are you presenting material? Are you sharing material? Are they engaging material? Those are the factors that can block or facilitate learning. And each one of those has its foundation in a learning theory. One of the more recent 2018 literature that if you're interested in reading, Joshua, a colleague of mine who's at the Mississippi State in the US right now, he wrote a fairly interesting book on how humans learn. And again, I'll run through a few of these highlights. And he says for anyone, students in particular, to learn, we have to be, we can't be scary. And people may say, well, my goal isn't to be scary, but let's face it, sometimes students think of professors and instructors as the power. You're the one that gives them A's, B's, and F's, and you're the one that know it all. So we've got to kind of reduce some of that anxiety that students have, because anxiety has got to basically affect a student's curiosity. I know some of these aren't going to be easy to take, but we have to reduce that lecture. Students' brains, people's brains, see lecture as an inauthentic activity. And I've seen brain scans on this when people are lecturing and it just doesn't light up. And it breaks my heart because I know that a lot of us work really hard on these lectures and we go there and we feel stress and adrenaline and nervous and we're presenting. And I kind of wish we could look out at the audience and just look at their brains because there's nothing happening. There is nothing happening. So you might as well not do it, right? I mean, it's just kind of wasting people's time. But think about when there are times for you to speak, for them to speak. You know, we talk about student and teacher speak. So reducing, I didn't say eliminating, reducing the amount of lecture is going to be really helpful. Just caring. Hopefully when you see some of these terms, you're thinking how much you do it, but I tend to think about how much some of my instructors did or didn't. In my undergrad in particular, I went to a Florida Institute of Technology, great place, but I can't really recall any of my instructors caring for me as a human being. They were typically engineers and scientists, and they cared a lot about the discipline, but they didn't care about me as a human. Therefore, my ability to process information was kind of up to myself. I had to do that myself. The last thing that Josh talks about is minimizing grades. If it were up to me, which is not, no one's ever asked me this, I would eliminate grades altogether. I think grades serve no fundamental purpose in education. They serve plenty of purpose in filtering and job maybe selection, peer pressures, a lot of the negative aspects of society. Grades reinforce that. They separate us as humans. They categorize us. They demoralize a lot of our students. I think grades are one of the biggest problems that we have in education. And Josh obviously agrees. Josh has research backed on this. But instead of grades, we need to provide timely, critical, helpful feedback. And again, only you know that. It does take time and energy to do this. But I would strongly recommend that we do more of that. You know, figure a way through that to come up with some obligatory letters that institutions require from us to do. So all of this is to build up to this particular screen. And I will say that if there's only one slide that you really kind of imprint upon for this particular session, I hope it's this one. I'm going to spend a little bit of time on this. This happens to be the information processing, Atkinson and Shiffrin, 71. Atkinson used to be actually the chancellor at University of California, San Diego, where I used to work, really kind of world-renowned and educational psychologist. And they came up with this, what's called the dual memory model. And if you haven't seen this, it looks relatively simple, and I'll share how this works. Whether we like it or not, this is how our brain works. This is what you're doing this very minute, and this minute, and this minute. You're doing it whether you like it or not. And here's how it works. Basically, we all have some inputs. So right now you may have my voice, you may be hungry, thirsty, you may be tired, maybe the sun is setting, maybe it's kind of hot or cold. We're constantly having inputs, and we're sensing this with our eyes and our ears and our mouths, and these are our inputs. What I need to do, if there's any kind of next step, is I need to basically do something that gains your attention in a sustained way. That's why I try to have inflections in my voice. I try to have some graphics that may catch your attention. I may try to do anything I can to help move this along, to move just an input into you truly sensing it, and then moving that information over into what we call STM. This is short-term memory. Some people call it working memory. And during this phase, most people take about 5 to 6 seconds, and they're constantly asking themselves one question, really one very basic question. Is that information useful to me? If you're younger, you may add now. Is it useful to me now? I may not be able to think about the future, but is it useful to me now? That's why when you say things like, oh, this is going to be on the test, then all of a sudden it is useful to them now. It doesn't do any good in the long run, but they will do something with that information a little bit differently. What we want to do is we want to make it as engaging as possible, that they make the decision, ultimately intrinsic as opposed to extrinsic grades, value, rewards. But they make the decision that that's worthwhile, and therefore they will kick it over, they will move it over into what's called LTM, long-term memory. So short-term memory, long-term memory, yeah, great, absolutely. Sometimes we also remember things that are useless but are interesting too. That's a huge, thank you, Danny. That's a huge point. It's funny because I could probably challenge each of you to think of something that you remember when you're 5 years old, 10 years old. There used to be this game, it's probably still around, called Trivial Pursuit. And I used to be pretty good at it, and I would answer questions. I would have no idea why I knew these answers, right? Just the most esoteric, silly things. But yeah, somehow something was going on in my life when I was 5 years old or 10 years old that I was able to process that information into long-term memory. And this is a great connection because once it's there in LTM, it's there. Now it may be hidden, it may be deep, but it is there. And then upon appropriate prompts or cues, and that's the little line, you can recall that. And that's exactly what Danny was talking about, that these things that may seem just odd is that you're in the right place or you're smelling the right thing. It's funny, I'll tell a quick story. When I grew up, my father was a high school teacher, a biology teacher in a very small town in the middle of the United States, in the Midwest in Indiana. And I spent a lot of time as a 5-year-old, 6-year-old in that back room. And I'm assuming everyone knows a biology lab has specimens, worms and grasshoppers and frogs and things like that in a biology room. And at that point in the early 60s, they would preserve those specimens with a chemical called formaldehyde. I don't know if anyone has smelled formaldehyde or really any aldehydes. They're alcohol derivative, and they're very, very pungent, right? They kind of preserve these. And so I spent a lot of time in that back room when I was young. Maybe that's what happened to my brain, I don't know. But years later, I smelled that someplace, and I recall very clearly thinking, wow, that smells really good. And I wasn't smelling the formaldehyde, I was smelling the memories, right? I was smelling the context. You may do it with apple pie, you may do it with all types of things that you remember eating, smelling, very, very powerful. Those sensories, as we see in this information processing, can play a vital role in how we can process this. Now, one thing I'd like us to be very clear, because this seems overly simplistic, this model, is that one of the major challenges is how we what's called code and decode. So I kind of I talked about this in a very linear way of short-term, long-term, so forth. So that would be what's called the coding phase, is how are we actually coding, processing, manipulating, putting this information in our brain so that it's there for decoding. And overly simplistic is that, for instance, if you were to lecture in a very linear way, that would be called the decoding. And then if you were to assess what they coded, if you did that in another linear way, let's say a multiple choice, low level knowledge-based test, they probably could do it. Students, However, if you were to code in a linear way and then decode, assess, in a nonlinear way, like project-based, experiential learning, service learning, chances are when the students searched for that information in their cognitive memory, they probably wouldn't be able to find it, even though it's there. But the roadmap they made in their brain didn't take them to there. So it isn't as simple as just throw stuff in there. It's kind of like going up into your attic or to a storage unit and looking for something, but not knowing the map to get to that area. So along with the processing, you have to have a very clear kind of a breadcrumb or a trail to allow you to get back to those. And the best way this works is if we make multiple trails, multiple paths. I call them sticky points. So there isn't a ABC, there's A goes to C, D goes to C, Z goes to C. There's multiple ways for us to go, oh yeah, I get that. And that's part of the neuron processing is the more sticky points, the quicker you are at actually processing, making sense. And that's why I strongly recommend that instead of teaching facts in isolation, we teach about connections. My course in environmental chemistry is all about connections. I don't test them on the structure of benzene or the ionic anionic charges. I test them on the connections between benzene and toluene, the connections between benzene and gas stations, or gas stations and health, or so it's those connections, because I want to build the neural memory of their connections. And I hope that when you listen to this, you're starting to make this your own. Like when I teach, again, accounting's on my mind, how am I really helping them not to develop a spreadsheet, but how am I helping them understand the connections between this spreadsheet and real life, or this spreadsheet and finances, or this spreadsheet and the cost of homes in Oklahoma, whatever, right? Whatever those connections might be that could really be powerful ways that they can extrapolate that information for other ideas. So you can see how this is really key this is a learning theory. This is one of the major learning theories of information processing. There are ways, as you see between STM and LTM, that's like the secret, the magic. There are ways that you can actually increase this attention. One of them happens to be, and I've got that written here in the blue bullets, mnemonic devices. You may remember some of these as a child, like Roy G. Biv is the name of the colors in the spectrum, red, orange, yellow. You probably have all kinds of these that you might remember. Chunking is that really kind of an interesting that PowerPoint has made a lot of money on. We tend to recall and can make sense of, 3 to 5, 5 to 6 pieces of information at a time. That's why the whole point of PowerPoint was at the top, you have the title of the conceptual framework, and then you have the concepts inside that. And then students can remember that all belongs in the same frame, the same slide. That's how our brain is working. So it's up to you, the designer, to make sure that makes sense, because they're looking to you to help them chunk those informations so that later on all they have to do is to make the connections between those chunks. And then now they've got a very powerful series of chunks that they can attach to. And serial positioning is one of my favorite. This happens all the time, whether you know it or think about it. If I were to verbally ask you to go pick me, buy 10 items at the supermarket, at the grocery store, you didn't write them down, you left and you went to go purchase those. Which of those 10 would you most likely bring back? Some people say the first, some people say the last, and I would say, yes, that's the whole point of serial positioning. Chances are you're going to forget the ones in the middle. You're going to forget the ones that are typically called the nested. Yep, great, thank you very much, Danny. Excellent. The first, last, or something unusual. I love it. That's a great addition, Danny. Something unusual. So if I were to ask you to get something very specific, and that's a great way to think about serial positioning when you're teaching. That's why we tell stories. That's why we try to connect to certain things. The students will remember that forever if we can give them a little something unusual. And so I think a lot of good teachers do that, knowingly or not. They try to really embed some authenticity in that. But the whole point of serial positioning is, what those complex concepts are. So I would just encourage you that when you design that learning experience, don't put those in the middle. Put some of the ones that maybe are a little bit easier or they could do on their own, but put the really complex concepts at the beginning or at the end. There's many other aspects that are very complex: metacognition, self-efficacy, self-regulated, constructivism, social cognition, dialectivism, that could go into this. So it isn't as simple as it seems, as kind of this linear flow. Matter of fact, this is a slide of some of the times that I mentioned. Again, it's all roughly, there's ranges and variants of these times, mainly because we are different people. We have different abilities physically and mentally and backgrounds. And so there's some ranges, but this is really a little bit more how we work and we sense and we recall and we rehearse, and ways that we can kind of, but you can see the line on forgotten. There's a lot of things that are basically diminished or forgotten through time. And that may have happened to you as well. But the one that I like the best is this one, which really reminds us how complex things are in our brains. So this is just an example of, the ones that I put in the red boxes are the ones that I showed on the first slide. I want to remind us that it seems simple at first, but processing, memory, learning is very complex. That's why we have experts such as you in the field to really help escort our students through making sense of a lot of our content, a lot of our conceptual frameworks, so they can use those in the future. All right, so hopefully that was really somehow imprinted on you, that slide. So let's take this for a spin. I've got a few activities for us to think about. This one's very simple. To yourself, sitting quietly, just do me a favor and count the number of F's that you see in this passage. Great. Yeah, when you're done, if you just want to put a number in the chat. Excellent. Thank you. You're way ahead of me, just so that I can see, and no judgment here, just so that I know that we're ready to move to the second one. I see some numbers out there. And I'll just go ahead and share with you the answer. There's actually 6. By the way, this is not a diagnostic. This is not an intelligence test. It's not even a vision test. This is an information processing, not even a diagnostic. It's just a way to share how people process information. Often, some people say there are 7. They count the one at the top. That tells something else about those folks. But often when we read this, especially if English is not your first language, but myself, when I read this and I read the word of, O-F, I hear a V instead of an F. And so I may not count it. Or it's so small, I may just kind of move by it and I may not count it. And I may come up with 3 instead of the 6. I share this because I think that even though you're sitting quietly, comfortably, focused, some of us still get the incorrect numbers. How do you think students are processing your slides, which are obviously much more complex than this? Do you think that they're picking up on all of the aspects of this? Chances are they may miss a few. And so this is another reason to wait, to have some formative assessments, checking to see what it is that they did. Maybe counting those F's and the ofs wasn't critical, so I may just move on. But I kind of like this as a reminder that we process information in different ways than we may. So let's do this one. Now, this is a physical one. Let's sit comfortably at our seats, everybody. And then while sitting there, let's lift our right foot up just a little bit off of the ground and start to make clockwise circles with our foot. Now keep doing that. At the same time, take your hand, put it up in the air, and draw the number 6. What happens to your foot? I don't know about yours, but mine kind of does whatever it wants to. I can't really keep it going where it was going. So the brain, right, is sometimes thinking if you kind of really try hard, I can get them working. But there's a lot of energy going on there. Some people can get that to work. So the brain is processing things, right? It isn't just our eyes. It isn't just our sense. It's physically, our brain is constantly trying to make sense of things, and we can help facilitate that, or we can just let it go. I do want to share a quick little video here. Great, get some chats. Thank you. Love the humor. So this is an activity. It's a video. You can see it's 1 minute 41 seconds. So it's about 100 seconds. I'd like you to basically watch this video and then count how many times that the player's wearing a white shirt pass the ball. Let me see if I can. Switch over to. All right, just checking. Can we all see this video? Okay. Could we hear that? Doesn't matter if you hear the volume, it's going to have it in text anyway. So go ahead and. And we all got that correct, I'm sure. Be honest. I did not. I missed it. Not even close. I thought they showed me a different video when they first showed me this. I was oblivious. I got all the passes correct, but I was oblivious. They could not see that at all. So what's the point? Why did I show that? I'm trying to share information processing, and now I'm trying to unpack it, because sometimes I feel a little bit bad that I make it sound simple, and it's not that simple. We have a lot of distractions that are interrupting our short-term to long-term memory. I mean, life and society is constantly bombarding us. So there's a really interesting a novel written by Somerset Maugham called The Razor's Edge. Happened to be a movie made by Bill Murray, one of his few, I think, dramatic roles. But the whole point of it is that he's trying to find the meaning of life, and he only finds it when he's on top of the Tibetan mountains, all by himself. And the saying is that, life is like, making sense of life is like walking along a razor's edge. But when you're up with no distractions, you can do it, but otherwise you can't. And that's the challenge with information processing. That's the challenge with learning theories. That's the challenge with learning, is our students come to us with something that happened to them before they entered class. They may or may not be able to focus. We all have some things going on in our lives. And so we can't just treat this like a blank slate and think that, oh, well, students are going to go from, let me just tell them this, and they'll process it from short-term to long-term, and halas, we're done. That's not how it works. There's all kinds of other distractors. And that's really how this is coming into play. So it really depends on what you're looking for. You are asked to count the number of times. And so you were probably focusing on that. If I'd asked for you to watch for the gorilla, you probably would have found that, but you probably wouldn't have counted the passes. So now we're back into course design, course learning outcomes. What are you trying to actually help the students focus in on? Whatever that is, your course material, your experiences should obviously align very well with that. Here's a quick one on perception. Just see if you can, as quickly as you can, find the man's head in this coffee bean mess. It took me like an hour. Yeah, you guys are better than I. It's frustrating. So if you haven't found it by now, then you're the same as me. If you haven't found it, it's right down there. So there. If you found it in less than 3 seconds, congratulations, you are superhuman. If you did it 4 to 20, you're kind of normal. If you're like me, I've shown this a million times and I still have to look for it. I don't know if it's my eyesight. What I say is, as a chemist, I tend to be very analytical, and as a Western chemist, I tend to start from the upper left and go across the top. If it had been up there, I would have found it right away. And then I go down and down and down and down, but it was all the way at the bottom. So I didn't get to it till later. If you read right to left, maybe you would have gotten it even up to down, right? So it's how we process things. Somebody's able to look at it holistically and somehow scan and point it out. All that means is that everyone has this very differential way of processing, even through sight. And so when students look at your PowerPoint, what do you think they're looking at? Do you know what they're looking at? Do you know what they're getting out of each one? Now, you sat there and you spent a lot of time to create that. Do you know that it's working at all? And if so, maybe they didn't find the man's head. Maybe all they saw was a bunch of coffee beans and thought, why has he created this slide? Why is she doing this? So this is a whole nother reason to think about sharing some sort of quick check and balances. All right, excellent. Yep, long-term memory. Love the connection. Thank you, Ann. All right, I do want to share a couple, we've got about 5 minutes left. I'll share a few other ways that you can help yourself and help faculty, help students. The whole point of this session is to help them connect to learning theories, is by offering something like a concept map. We talked about connections before. The whole point of a concept map is to integrate new and old knowledge, brainstorming, assessing, diagnosing, is to think about how they might to make some of these connections. And people probably are recognizing my my graphic. It's all about, the Shanghai subway system is a great thing to think about connections, right? If you want them to get from X to Y, sometimes it takes a few stops to get to understand some things. And as an example, this is one of the carbon cycle that you can think about. Most of the time, these concept maps come with two major types of assets. They have something in the box, and then they have something outside the box. The outside the box is always what's important to me, and for the concept mapping is what we call these transition terms. These are the terms that help describe the relationship between one term and another. And graphically, after you're finished with these, you can see holistically the relationships between all of these concepts and understand the actual conceptual framework. Far too often we have students define these in isolation, so they might know everything about respiration, but they have no idea what respiration has to do with, chemosynthesis or photosynthesis and so forth. So this is a really nice activity. I do this a lot of time as a pre-assessment at the very beginning of the course. We have some fun and we learn a bit, and then I do it again at the post. And I look at this as some growth. I show it to students. They, I think, have fun with this, going, wow, their words, not mine. I really didn't know anything when I came to class. And I'm surprised on how much I know now. So I don't consider it a test. I consider it kind of a diagnostic that they come to these conclusions. Another way to think to help them facilitate this processing that we talked about is what's called hexagonal thinking. I don't know how many people are using this. It's similar to a concept map, but a concept map, as you see, sometimes has just one or two lines. Hexagonal thinking really is more of a jigsaw. And we all know that each concept has multiple connections to another concept. At times I will get some of those Post-it notes, but instead of square, I will try to purchase some of those that are hexagonal so that you can kind of connect them to each other. And you see it turns into a really intricate puzzle, and trying to help students see, where does this fit in the puzzle? And I think there's a lot of awakenings, lots of processing going on of, oh yeah, I didn't realize that this is connected here and this affects this and this becomes this, and you could color code them, you can do things, but this is a whole lot closer to how the brain is actually functioning than writing down things on a piece of paper in a very linear way. So that might be one kind of tip that you might think about doing with your classes in the near future. I'm happy to share, I shared a lot of information there. I didn't really touch upon how deeply some of these things go, like constructivism and self-regulated, even into social cognitive theory and operant conditioning. That's a whole lot of, if you want some of that information, I can either share the text with you on a shared Google document. We can chat, anything I can do to provide you the information, what you want, when you want it, how it will help support your teaching today, next week, next month. I know you're extremely busy trying to teach about 1 million courses. I've got just a couple minutes. I do want to, I share with some examples. I like to teach it in what's called an example, non-example mode. I want to share with you some non-examples of how we think students process, but they don't. Fairly recent research coming out on what's called neuromyths. So how these neurons are connecting and not connecting. This concept of learning styles, which if you've been in any of my sessions, I tend to make that a bit of a pet peeve because they simply do not exist. If you would like this, I will send you a very extensive literature review. I'm hoping that we can stop using this in our vocabulary. I can tell you quickly, the instructors that at least are open to research will have stopped using this term because it simply doesn't exist. We do not have preferred learning styles. If we are presented something in a visual or auditory or kinesthetic, it simply does not mean that we can actually perform better. So please, I encourage you to stop using those. Secondly, there is no left or right brain. It's not that simple. I wish life was that simple, but it's not that simple. And you may have heard this whole, we only use 10% of our brain, which I think we would stop breathing if that's the case. So these are some simple things that we probably should stop Googling, but things that do have impacts, right? Our emotions, we talked about that earlier. Explaining the purpose of the activity, that's part of andragogy, that the adult learning processing. A positive, helpful, caring atmosphere. Meaningful, timely, formative assessments, and this idea of stress that's going to stop our brains from coding, encoding, decoding. These are the things, and as you can see, these things all align very clearly with learning theories and information processing. All right, I am going to. It is now time, so I'll share any of this other information, which is just supporting kind of where we were headed. And more specifics. I wasn't sure how long this would kind of take to go through that. But that is the end of today's session. I will stop sharing. I will stop